In a world where advanced technology dictates global power, one country has just pulled off a feat that many thought was impossible. China has successfully produced 2-nanometer chips without relying on US tools or technology. This breakthrough is more than just an engineering achievement. It represents a seismic shift in the balance of power within the semiconductor industry and could reshape the future of the global tech economy. For years, the United States has held dominance in semiconductor equipment, controlling access to the most advanced chip-making machinery. Companies like Applied Materials, Lam Research, and most importantly ASML in the Netherlands, have had the keys to producing chips smaller than 5 nanometers. Without these tools, it was believed no country could advance to the next generation of processors. But China has just proved the world wrong. For context, a nanometer is 1/1,000,000th of a meter, and the smaller the number, the more powerful and efficient the chip becomes. 2 nanometers chips are a major leap forward. They allow more transistors to fit on a chip, meaning more processing power, lower energy consumption, and greater performance across everything from smartphones to artificial intelligence, military systems, and even space exploration. Until recently, 3 nanometers chips were considered the cutting edge, pioneered by companies like TSMC and Samsung, who relied heavily on US and allied technologies. But China's achievement of 2 nanometers chips, without access to these tools, signals a new era of self-reliance and innovation. The significance of this milestone cannot be overstated. For years, the US has imposed export bans and sanctions on China, aiming to limit its access to high-end semiconductor technology. The idea was to keep China a step behind in the global tech race. But instead of slowing them down, these restrictions may have accelerated China's determination to innovate on its own. What we're witnessing is a bold demonstration of technological sovereignty, China showing the world that it no longer needs to depend on American tools to compete at the highest level. But how did they do it? Reports suggest that Chinese engineers developed alternative lithography techniques, unique manufacturing processes, and creative workarounds that allowed them to bypass the restrictions of US-made equipment. Instead of relying on the extreme ultraviolet lithography (EUV) machines that only ASML produces and the US restricts, China may have refined older deep ultraviolet (DUV) tools to achieve results previously thought impossible. It's not just about building chips, it's about rewriting the rules of what was considered achievable. This breakthrough has immediate global implications. First, it challenges US dominance in the semiconductor supply chain. If China can mass-produce 2 nanometers chips, it could dramatically reduce the dependence of its own tech companies on foreign suppliers. Companies like Huawei, which face setbacks due to US sanctions, could now be powered by domestically produced 2 nanometers chips, giving them a massive competitive advantage. Second, it reshapes the competition. Nations like South Korea, Taiwan, and Japan have been at the forefront of chipmaking, often with US backing. But now, China stands shoulder to shoulder with them, without the same dependency. The ripple effect will spread far beyond China's borders. Other countries may begin to question whether US technology dominance is still unbreakable. The idea that only a handful of Western-aligned nations could produce next-generation chips has now been shattered. This opens the door for a multipolar semiconductor landscape, where innovation isn't controlled by a single bloc but instead contested on a global scale. There are also geopolitical consequences. Semiconductors are not just about powering iPhones and laptops, they are the backbone of modern economies, militaries, and entire infrastructures. Whoever controls chip technology controls the future of artificial intelligence, advanced weapons systems, quantum computing, and more. By breaking free from reliance on US tools, China is signaling that it's ready to stand as a technological superpower, independent of Western constraints. For Washington, this is a nightmare scenario. The export controls that were designed to hold China back are beginning to lose their leverage. If China can innovate its way out of restrictions, sanctions lose their bite. At the same time, this doesn't mean the US is out of the game. America still leads in chip design, software, and many advanced materials. But the monopoly on manufacturing tools, the critical choke point, has just been broken. The world is moving toward a new balance, where technological leadership is no longer one-sided. Looking ahead, The real question is how fast China can scale its 2 nanometers chip production. Creating prototypes is one thing, but mass production is an entirely different challenge. Yield rates, efficiency, and consistency will determine whether these chips can compete globally. But if China succeeds in scaling, it could shift supply chains, pull in global customers, and even threaten the dominance of TSMC and Samsung. This breakthrough also raises another issue: trust. Will the global market trust Chinese 2 nanometers chips in terms of quality, reliability, and security? For many companies and governments, the answer may be yes, especially if the chips deliver on performance and cost. For others, particularly Western allies of the US, skepticism and political pressure may prevent widespread adoption. Still, the fact remains that China has reached a milestone once thought impossible. We are entering an era where technological decoupling between China and the West is no longer just a threat, it's a reality. The more the US tries to limit China's access, the more China invests in creating alternatives. And now, with 2 nanometers chips on the table, the dynamic of control has shifted dramatically. This moment will likely be remembered as the point when the semiconductor race entered a new phase, a phase defined by resilience, independence, and the relentless drive of human ingenuity. As the world reacts to this stunning announcement, one thing is clear: the balance of power in technology is shifting before our eyes. China producing 2 nanometers chips without US technology is not just an industrial achievement. It's a declaration of intent, a message to the world that no sanctions, no bans, and no restrictions will stop its progress. And in the global race for innovation, that determination might be the most powerful tool of all. This achievement by China didn't appear overnight. It's the result of years of strategic planning, billions of dollars in investment, and the mobilization of some of the brightest minds in the country. When US sanctions tightened and access to advanced tools was cut off, China doubled down on its national semiconductor strategy. The government poured resources into research and development, encouraged domestic companies to push boundaries, and built a framework that treated semiconductors not just as an industry, but as a matter of national security. That long-term commitment is now paying off. To understand why this is such a big deal, we have to rewind to how semiconductors became the core of modern life. Every smartphone, every laptop, every car, every medical device, every missile defense system, everything that defines our era relies on chips. Without them, societies as advanced as ours simply stop functioning. This is why the US guarded semiconductor equipment so closely, and why Taiwan's TSMC became known as the most important company in the world. If you control chips, you control the future. But now, with China reaching the 2 nanometers threshold independently, the monopoly on progress has been disrupted. The US will not stand by quietly. Expect responses in the form of tighter sanctions, diplomatic pressure on allies, and even attempts to restrict global adoption of Chinese-made chips. But here's the problem: the more the US tries to limit China, the more it demonstrates to the rest of the world that alternatives are necessary. Countries that once aligned completely with Washington may now see opportunities to collaborate with Beijing. After all, if China can produce advanced chips without American tools, why should nations lock themselves into dependency on US tech giants? This also places immense pressure on Taiwan and South Korea. For decades, Taiwan's TSMC has been the crown jewel of global chipmaking, and South Korea's Samsung has stood as a close rival. Both relied heavily on US tools and technologies, but both also benefited from being the go-to suppliers of the world. Now, if China scales production of 2 nanometers chips, TSMC and Samsung could lose customers, markets, and influence. And because Taiwan is already a flashpoint of geopolitical tension, this new shift only adds more complexity to the region's fragile stability. Meanwhile, China's domestic companies are the biggest winners. Huawei, which was crippled by US sanctions, could suddenly find itself revitalized, powered by Chinese-made 2 nanometers processors. Tech companies across Beijing, Shenzhen, and Shanghai will no longer have to fear being cut off from progress. This breakthrough could trigger a renaissance in China's electronics industry, driving innovation in AI, robotics, quantum computing, and more. The West, on the other hand, faces a tough decision. Does it double down on trying to isolate China, or does it adapt to a new reality where technological power is more evenly distributed? If history has taught us anything, it's that innovation can't be contained forever. The space race didn't end with one country holding the monopoly on space exploration. The same will be true of semiconductors. What makes this development so fascinating is the way it changes the psychology of global competition. For years, the assumption was that China was a fast follower, able to replicate existing technologies, but not capable of leading innovation in the most advanced sectors. That assumption has now been shattered. Producing 2 nanometers chips without US tools is not just catching up, it's leaping ahead in a way few expected. It tells the world that China is not just a manufacturing powerhouse, but also a technological leader capable of rewriting the rules. Of course, challenges remain. Mass production is not easy. Advanced chipmaking requires not just breakthrough techniques but also precision at a scale almost impossible to imagine. One small defect in a process measured in billionths of a meter can mean an entire batch of chips fails. The real test for China will be whether it can replicate this success at scale, at cost, and at global standards. But the fact that the barrier has already been crossed means that even if it takes time, the door is now open, and it won't close again. The global tech community is now on edge. Competitors will rush to accelerate their own roadmaps. Investors will pour money into semiconductor startups and alternative technologies. Governments will re-evaluate their strategies. And ordinary people, even if they don't realize it, will eventually feel the effects, in the speed of their phones, the intelligence of their devices, the security of their data, and the cost of their electronics. This moment could very well be remembered as a turning point, the day the semiconductor race stopped being one-sided and became truly global. Just like the Industrial Revolution or the rise of the Internet, the birth of independently produced 2 nanometers chips in China marks a milestone that reshapes the future. The story is still unfolding, but one thing is certain: nothing in the world of technology, geopolitics, or economics will ever be quite the same again. The rise of China's 2 nanometers chip achievement without US tools is not just another headline in the tech world, it's a redefining moment in human progress. For decades, the semiconductor industry has been shaped by a handful of countries and corporations, with the United States holding the strongest grip through its dominance in chip design software and manufacturing tools. That grip is now loosening. What was once thought to be impossible has been made possible. The ripple effects of this breakthrough will move far beyond factories and cleanrooms. They will shake boardrooms, government offices, and research labs across the globe. This is more than about chips. It's about independence, resilience, and the relentless push for progress. China has sent a message loud and clear: sanctions and restrictions may delay progress, but they cannot stop determination. Every time one door is closed, another path is carved open. This moment symbolizes that spirit of defiance, that refusal to accept limits imposed from the outside. And whether you admire or fear China's rise, the reality is undeniable. This is a breakthrough that changes the balance of power. The world now stands at a crossroads. On one side, competition could intensify into an all-out technological Cold War, where nations isolate, decouple, and guard their knowledge with suspicion. On the other side, this could ignite a new wave of innovation, where breakthroughs by one nation push others to think bigger, invest deeper, and reach further than they ever imagined. In both cases, humanity as a whole is moving into a future where the impossible keeps being proven possible. For the United States and its allies, this moment is a wake-up call. The strategy of containment may no longer work in a world where ingenuity cannot be fenced in. For China, it's a proud declaration that it has arrived, not just as a participant in the global tech race, but as a leader capable of charting its own course. And for the rest of the world, it's a signal that the semiconductor landscape is no longer controlled by one side of the planet. As we close this chapter, one truth stands out above all others: the race for technological supremacy is not ending here. In fact, it's only just beginning. 2 nanometers chips are not the finish line, they are a starting point for the next frontier of human achievement. The devices you hold in your hand, the cars you drive, the systems that run your cities, even the intelligence that powers the AI of tomorrow, all will be shaped by this silent revolution taking place at the smallest scale imaginable. The question is no longer whether China can keep up. The question is whether the world is ready for what happens when it does.